Welcome ASs. We're going to be looking at exercise 16a, and the first question asks you to complete this table that you see on the screen here. It's also in your textbook. Now what we notice is they've given us cos theta in the first one and told us that cos is negative. That means that it must be either in quadrant 2 or 3. They've also told us that the angle is a reflex angle, which means we must be in quadrant 3. Okay, the 5 and the 13 represent the adjacent, and the hypotenuse, because that's what the cos ratio is. So for us to get the opposite, we're going to have to use a Pythagorean triangle. Now, you should know this triangle already from experience. So the answer is that 5 squared plus 12 squared is equal to 13 squared. So therefore the opposite side is a 12. Now, being reflex and in quadrant 3, both the x and the y's are negative. So that means that our sine theta must be negative 12 over 13, the opposite over the hypotenuse. And our tan will be the negative 12 over the negative 5, which makes positive 12 over 5. And of course you know that tan is positive in the third quadrant, so that confirms that we have a positive result with the two negatives one over the other. Alright, we're going to do exactly the same for the next one. So we've got sine this time, which is your opposite over hypotenuse. Our adjacent here will be 4, because it's a 3, 4, 5 Pythagorean triangle. Also, we've got an obtuse angle here, which means we are in quadrant 2, because sine is positive in quadrants 1 and 2, but if the angle is obtuse, then we must be in quadrant 2. So therefore, the cos will have to be negative, making this minus 4 over 5, the adjacent over the hypotenuse, and the tan will be the opposite, which is 3, over the adjacent, which is 4, and of course tan is also negative in quadrant 2. Right, for the third one, C, we've got 7 over 24. That would be the opposite over the adjacent. That would make our hypotenuse 25. And we're in an acute angle here, so all the ratios are positive. So here we've got 7 over 25, and here we'll have 24 over 25. Okay, and then for the straight line, we know that a straight line is 180 degrees. So basically we want to know what is the sine of 180, the cos of 180, and the tan of 180. And those answers are respectively 0, minus 1, and tan of 180 is also 0. So there we go, we've completed number 1. Right, we'll move on to number 2. So number 2 says we must simplify the expressions. We're starting off with 1 minus 6 squared a. And then we've got that over 1 minus cos 6 squared. Alright, so 6 squared is 1 over cos, so we'll write 1 minus 1 over cos squared a. And cos 6 squared is 1 over sine, so we'll write 1 over sine squared a. Now we'll find a common denominator on the top and the bottom. Okay, so that means we'll have cos squared minus 1 all over cos squared, and that will be then over, let's move this a little bit lower, that will be over sine squared minus 1 all over sine squared. Just found a common denominator on each of those. But we know that cos squared minus 1 is an identity that says sine squared plus cos squared is equal to 1. So sine squared plus cos squared is equal to 1 means that I can say that cos squared minus 1 is equal to minus sine squared. So I'm going to write minus sine squared at the top, and then have that over cos squared. And then we'll put the big division line again. And here we'll say that sine squared minus 1 is the same as, if we replace sine squared plus cos squared is equal to 1, we can write sine squared minus 1 is equal to minus cos squared if we rearrange. So minus cos squared over sine squared. But now we've got fractions over fractions, so I'm going to rewrite this up here, and we're going to say that we've got minus sine squared over cos squared, and we'll divide by that, so we'll multiply by the inverse, which is sine squared over cos squared, also minus. Okay, and that leaves me with minus sine squared times sine squared, which is minus sine to the fourth, or sine 4a, all over minus cos to the 4. The minuses will cancel, and sine over cos we know is tan, so we end up with tan to the 4a for number 2. Right, so then we're going to go to number 3, which is sine theta over cos theta plus cos theta over sine theta. Now there are probably a couple of ways to attack this one. Let's do one of them like this. Sine theta over cos plus cos theta over sine. We could use an identity straight away and write the following. Tan theta plus cot theta, which is 1 over tan theta. And if we found a common denominator here, we'd end up with tan squared theta plus 1 over tan theta. But tan squared theta plus 1 we know is an identity, and that is 6 squared. So then we'll have 6 squared theta over tan theta. 6 squared we know is the same as 1 over cos squared. So I can write this as 1 over cos squared. Now if I divide by tan theta, it's the same as dividing by sine over cos, but that would be the same as timesing by cos over sine. And one of the cos's will cancel, leaving me with 1 over cos times 1 over sine, which is basically sec theta and cosec theta. Right, so sec theta and cosec theta. I'm just going to move that a little across so you can see it there. Right, so sec theta and cosec theta. Sorry, that was number 4. I skipped number 3. I'll go down to number 3 in a moment. Let's just check that those answers are all correct in the back of the book quickly, so that you're not losing our way here a little bit. Right, so 16a. Yep, sec theta and cosec theta is correct. Alright, so we'll quickly do number 3 there as well. Number 3 at the bottom says sine theta over the root of 1 minus cos squared theta. So we've got sine theta over the root 1 minus cos squared. Now again, my identity cos squared plus sine squared plus cos squared is equal to 1. If I take the cos squared over, I get 1 minus cos squared, so I'll have sine squared. So this is the same as sine theta over the square root of sine squared theta. But the square root of a square is simply sine theta over sine theta. So a nice easy one. This answer is simply 1. Okay, and number 5. So number 5 says root of 1 plus tan squared theta, 1 plus tan squared over the root of 1 minus sine squared. Now, 1 plus tan squared we already know from an identity, and again that one is sec squared. So that's the same as root of sec squared, which is basically just sec theta. And 1 minus sine squared is the same as cos squared, and the root of cos squared is simply cos theta. Now, we've got sec theta over cos theta, which is the same as sec theta divided by cos theta, or the same as sec theta times 1 over cos theta. but 1 over cos is sec, so sec times sec is sec squared. And I think we can leave that one like that. Then we're on to number 6. So number 6 says 1 over cos theta. Sorry. 1 over cos theta. And we've got the root of 1 plus cot squared. Now here again, 1 plus cot squared theta is an identity, and the 1 plus cot squared is simply cosec squared. So the square root of cosec squared is just cosec. So I end up with 1 over cos and also over cosec. But cosec, 1 over cosec, is simply sine. So then I can put sine at the top, which is sine theta over the cos theta, but we know that one already as well as tan theta. And so there we've got tan theta for number 6. And lastly, number 7 in that little section says the following: sine theta over 1 plus cot squared theta. Sine theta over 1 plus cot squared. Now again, 1 plus cot squared we already know as cosec. So that's cosec squared. So that's sine over cosec squared. But cosec squared is 1 over sine squared. So if I divide by 1 over sine squared, it's the same as multiplying by sine squared. And so sine times sine squared is sine cubed theta. Right, so that takes us up to number 7. Right, so now we've got another series of questions. And these are the ones where we're going to eliminate theta from the equation. Alright, so the first one they give us is that x is 4 sec theta. So this is number 8. They also tell us that y is 4 tan theta. Okay, so if x is 4 sec theta and y is 4 tan theta, let's see if we can play with these a little bit. Okay, so if I square both of these things, I'll get x squared and y squared. Okay, but what would the square be on the other side? Well, let's have a look. X squared will be 16 sec squared theta, and y squared will be 16 tan squared theta. Okay, so that doesn't look like there's too much change, but we do have some identities that involve sec squared and tan squared. Okay, and if we said 16 sec squared minus the 16 tan squared, okay, so let's write that. So I'm going to write x squared minus y squared, and I'm just looking at the identities and seeing how they operate together, and I can see there is one identity that has tan squared and sec squared. So if I write sec squared, or 16 sec squared minus 16 tan squared, okay, I can write the following: sec squared minus 16 tan squared. And I could factorize this out and say x squared minus y squared equals 16 sec squared theta minus tan squared theta. But now I can see that sec squared minus tan squared is actually equal to 1. So therefore the x squared minus the y squared is equal to 60. And suddenly all thetas have been removed from that equation, and I now only have x squareds and y squared. So there's number 8. We're now going to move to number 9. Number 9 says the following: x is a cosec theta and y is b cot theta. Let's write those two. X is a cosec theta and y is b cot theta. Okay, so cosec we know is 1 over sine, cot is cos over sine. We might need a square identity here again, because we do have an identity that involves cot squared and cosec squared, so I think squaring here might be an option again. So let's try. We'll square these. Okay, if you don't try the right thing at the first time, you might need to try some of these again. But like I say, I'm just playing and seeing what I've got available. Well, if I square both sides, we get x squared here, and we'll have an a squared, and we'll have cosec squared theta. And for y squared, we'll have b squared and cot squared theta. Okay, and again, I see that if I have a cosec squared minus a cot squared, then I could get a 1. Okay, problem is we've got some different equations here with a squared and b squared. So what I'm going to do is I'm now going to write x squared over a squared is simply cosec squared, and then I'm also going to write y squared over b squared is equal to cot squared. Okay, and so now I can write that cosec squared minus the cot squared is equal to 1. Okay, so cosec squared minus the cot squared must equal 1. But what is cosec squared? Well, it is x squared over a squared. So we'll write x squared over a squared instead. And what is cot squared? Well, that's y squared minus b squared. So we'll put y squared over b squared. And of course that equals to 1. And again, when we look at that equation now, we no longer have any thetas involved whatsoever. So we've eliminated theta from the equation. Right. So let's try number 10 now. Number 10 says that x is 2 tan theta. And then it says that y is 3 cos theta. Okay, and again we've got to eliminate the theta. So we've got tan and cos now. Okay, we don't have an equation that has tan and cos, although sec is 1 over cos. So maybe we could rearrange something with that. Well, let's try. Let's go with a square function again and see what happens. Okay, so if I square, I'm going to get x squared is equal to 4 tan squared theta, and y squared is equal to 9 cos squared theta. Okay, so now I can write that tan squared is simply x squared over 4. But I could also write that sec squared, which is the 1 over the cos squared. You see, because cos squared would be y squared over 9, therefore sec squared would be just 9 over y squared. Does that make sense? It's just the inverse. Okay, so if I divided the 9 first and got y squared over 9 for my cos squared, I'm just inverting that to get the sec squared. And that again gives me a nice one with the tan squared and the sec squared. So then we'll take those two and subtract again. So now we can say tan squared minus the sec squared, which we know again is equal to 1. And of course then we'll replace our tan squared, which is x squared over 4. And our sec squared, which is minus 9 over y squared, is equal to 1. And there we have an equation again without a theta involved. Right, and then we're on to number 11. I think I'm actually going to leave 11 and 12 and 13 because I think all of those are pretty much on the same vein. You can give those a try. So let's look at number 14 now, which says we have to prove the following identities. Okay, so we've got cot theta plus tan theta. Right, that's on my left hand side, and we've got to prove that that equals sec theta cosec theta. So remember, with any proofs, we're going to first work with this left hand side. Okay, so we know the left hand side is equal to this. Let's carry on with that. Cot we know is cos theta over sine theta, and tan is sine theta over cos theta. I'm going to find a common denominator here, which we can see is sine theta cos theta. And that means that I must multiply the top by cos, so that will become cos squared. I must multiply this side by sine, so that becomes sine squared. And immediately we can see that cos squared plus sine squared is 1, so we end up with 1 over sine theta cos theta. But 1 over sine theta is sec theta, and 1 over 1 over sine theta is cosec theta, and 1 over cos theta is sec theta. So I end up here with cosec theta and sec theta. And if now look at the right hand side, that is equal to the right hand side of the equation. So therefore I've proved the equation. Okay, so this is how we go about these. We prove the left hand side is equal to the right hand side when we see that it is, and then show that it's, then just say that it is equal to the right hand side, so therefore we've proved it. Number 15 in this one says that we have to write cos theta over 1 minus tan theta. So let's do that. Cos theta over 1 minus tan theta. And then we've got plus sine theta over 1 minus cot theta. Sorry, they used a, but theta's fine. We don't have to worry about that. It's just a different variable or angle. Alright, so for this one, we've got to try and prove that that equals sine alpha plus cos alpha. Now you might be tempted here to say, well, let's try and look for an identity, but I think the one that we're going to need to do is convert the tans to sines and coses. So let's see what happens. Okay, it's going to make it a little complicated, but it should work out in the end. So what we've got now is that this left hand side is simply equal to cos theta over 1 minus, and tan is sine theta over cos theta. And then we've got plus sine theta over 1 minus, and cot theta is cos over sine, cos theta over sine theta. I'm going to move this a little down again because we're going to go a little bit further here. Now we're going to have to find common denominators at the bottom, okay, because we've got fractions over fractions again, and we don't like those. So, common denominator for the first one is cos, so I end up with cos theta over, and then I'll have cos theta minus sine theta all over cos theta. Here I'll have sine theta at the top, and then the common denominator is sine theta, so I'll have sine theta minus cos theta over sine theta. Alright, so now it's time to reduce each fraction from a double fraction to just single fractions. Okay, so cos divided by cos minus sine over cos is the same as cos times cos over cos minus sine. Okay, so again, I've got cos theta divided by this thing. You see, it's divided by that. So it'll be times the inverse. So that means I've got cos squared at the top all over cos theta minus sine theta. And for this one, I've got sine theta divided by the sine theta minus cos theta over sine theta. So that's the same as sine theta times the inverse, which is sine theta times sine theta, which is sine squared theta, over the sine minus cos. Okay, all right. So now we've got at least just two fractions. Okay, so now what we're going to do is we're going to find a common denominator. Now, this one's actually a little bit easier to play with because we can see that this is cos minus sine, but the second one is sine minus cos. So if I took out a minus sign from here, then I could write the same denominator. Okay, because then I could swap this around and make that cos minus sine. So that's what we're going to do. So we end up with the following. We end up with cos squared theta minus sine squared theta over cos minus sine, which is the common denominator now. But the top there is a difference of squares, which can factorize to cos minus sine and cos plus sine. Sorry, let's just move this down a bit. So then I get cos theta minus sine theta and cos theta plus sine theta, and that's all over the bottom, which is still cos theta minus sine theta, and of course this will cancel with that, leaving me with cos theta plus sine theta, which happens to be exactly what they have on the right hand side. So once again we've proved that one. Okay, not too difficult, but it is a bit long-winded, but again, if you go slowly with the algebra, you'll get there. All of this is actually algebra. There's very little trig involved other than maybe one or two substitutions for the identities. Number 16 says we must prove that tan squared theta plus cot squared is equal to sec squared plus cosec squared minus 2. All right, let's start with the tan squared plus the cot squared. So we've got tan squared theta plus cot squared theta. Alright, that's my left hand side, so keep working with it. Should label left hand side again, and that would equal, well, I think I'm going to go with some identities here and let's see what happens, because we know that tan squared is sec squared minus 1. Let's put in. And cot squared happens to be cosec squared minus 1. And all of that just simply reduces to sec squared plus cosec squared minus 2, which happens to be my right hand side, and therefore we've proved that one. It was a nice easy one, didn't take much work at all. Okay. Now number 17 is probably not much different. You should be able to do that one quite comfortably. Okay, if you play with that a little bit. Number 18 is tricky, but use the hint. Okay, they told you to multiply the bottoms there by 1 minus cos A. So let's see if you can go all the way with those. If you can get all of those, number 17 and 18, then you should be nicely on track with solving some of these things. Okay, I will do number 16b in another session for you.